Okay, all right, great.
What is happening? Hazelton from the 403 to the HAZ. Mr. Nelson here. We are talking about logarithms, my friends. And in the last video, we kind of just got introduced to the laws of logarithms, and we did a couple examples. Now, I've put them up here nice and neatly, and I included our reciprocal one that I kind of added last minute. We have our product law, our quotient law, and then our power law. And these guys, these two laws here, these are going to come really in handy as we move forward and we start to solve equations involving exponents and logarithms. Also knowing that this is the inverse of an exponential function, and this is the same thing. These are just written in two different ways, but they are the same equality. So let's just do some more problems. Let's just keep going and practice. So let's say I gave us something like, log base 3 of x times the square root of y over c. Okay, and I want to express this as individual logs of x, y, and z. That's one thing that they'll ask us. So the first thing I know is that I don't want to have radicals, okay? I want this to be an exponential form. So the first thing I'm going to do is just rewrite this in exponential form, which I can do as y over z all to the power of a half. Okay, that was the first step. Now, I am multiplying, but I'm also dividing. So I'm probably going to be using my product law and my quotient law here. So the first thing I'm going to do is, I have x times this thing. So I'm going to separate that using my product law. Okay? And I'm going to start here because I need space. And I'm going to do it in red. I'm feeling red right now. Feeling that red. Okay. So I got log base 3 of x plus log base 3 of y over z to the 1/2. Okay, great. Now, this is pretty much done. There's nothing else I can do on this guy right here. Here, I now have a power and a division. So I'm going to, now I could either distribute the 1/2 to each, but I'm going to just get rid of that power first. I'm going to work my way out, okay? So that 1/2 is going to come in the front now. So I rewrite this as log base 3 of x plus 1/2 log base 3 of y over z. Okay, now all I have left is a quotient here, okay? And this 1/2 is multiplying by everything. So what happens is I get log base 3 of x plus 1/2 log base 3 of y minus log base 3 of z. And then I could distribute that, and my final answer will be log base 3 of x plus 1/2 log base 3y minus 1/2 log base 3z. And I'm going to check my answer because I am basically learning all this just like you guys right now. And look at us go. Excellent. Okay, that's how we expand that. They left it in this form here, but I just went and distributed. These are both correct answers. Okay, we did it. We did it. Hooray for us. Hooray for me, Billy. Hooray for me, Billy. Okay. Let's do another one. DJ Khaled asked for another one. Another one. Okay. Let's try another one.
going to stick to the textbook because I don't trust myself with this. Oh shoot, forget it. You know what? We're just going to get crazy. Here we go. Okay, let's do it. Let's just do it. I'm just going to try. And I'm going to fail forward. So I've got log base 3 of 9 all divided by the cube root of x squared. Okay. First thing I want to do is well, first thing I want to do is I want to get rid of that radical. I tell them, so let's rewrite this as, that's the first thing we can always do is get rid of that stinky little radical. So I can rewrite this as 9 over the cube root of x squared is the same thing as x squared to the 1 over 3, if you remember our exponent laws. If you don't, check that out. And then I can, using the product law of exponents, this becomes over 2 over 3, okay? So I can rewrite this down here as x to the power of 2/3. Excellent, okay. So now, looking at this, you know, there's several ways I could go, but I'm noticing right away this is a division. So let's just split this up using our quotient law in blue. So I'm going to use blue. And I get log base 3 of 9 minus log base 3 of x to the 2/3. Okay. Now, log base 3 of 9, I can actually figure out what this is equal to if I just kind of go back to what we were doing before. So I've got log base 3 of 9 is equal to something. What is it equal to? Well, I'm going to put it in this format now. So 3, which is my c, to the power of y, which is a question mark, is equal to 9. And 3 what? 3 squared gives 9. 3 to the y is equal to 3 squared, so y is equal to 2. So this is actually equal to 2, but we'll come back to that. Let's work on this here. Well, actually, you know what? I'm just going to write it. That's 2. This is 2 minus, now I've got the exponent here, so I'm going to use this law. So minus 2/3 log base 3 x. Excuse me. That's it. Okay, we did it. We did it. Should we do one more, guys? Let's do one more, and then we'll do the flip side, where we're going to be simplifying. So we're going to do one more here. Which one do I want to do here? I'm going to do, sure, okay, log of x squared over y and the cube root of z. Okay, so first thing I'm going to do is I don't like radicals. Let's get rid of that bad boy there, okay? So I'm going to rewrite this as just exponents. Log, now there's no base there, so we just assume it's 10. It's a base 10 because we live in a base 10 reality, or we approach our reality from a base 10 place, but in this case they didn't write it. We don't have to write it because we just assume x squared over y, and then remember the cube root of z is the same as z to the 1/3, and that's just our basic exponent laws, okay? And this is y to the 1 there. Okay, so I'm going to start splitting this up, and I'm going to use, in my first case, I want to get rid of that division. I'm going to use my quotient law here. And we're going to go into black again, the darkness. So I get log of x squared
minus log of y z to the third. Okay. I'm going to come back to this guy. Let's split this up. So now I'm in this scenario. I'm multiplying two numbers together in my log. So I'm going to split this up. So log x squared minus log of y plus log of z to a third. Okay? I split this up using this rule here. Okay? Now I've split them up, and now I just have to deal with these powers here that are left over, and I can just go right there. So this becomes 2 log x, I'm just getting rid of the exponent, putting it in front, minus log of y minus a third log of z. And I am done. I did it. Not so bad. And let's just make sure that I did it correctly, because I don't trust myself. And I gone done, did it correctly, guys. Gone done, did it correctly. Great. So this is my answer here. Okay? Not so bad if we just have the laws in front of us and we fail forward. It's like a puzzle, guys. You have the rules, and it's a puzzle. We have to figure out how to make it work without breaking any of the rules. Okay? So now let's start going the other way. And we'll start real simple. So I have, I'm going to start real simple. So I have log 12 of 24 minus log 12, 6 plus log 12, 36. Okay, and it says to simplify and evaluate. So the first thing I can do here is, okay, I'm subtracting and I'm adding, but I notice that I have the same base. And the fact that I have the same base means I can start using these rules here. So I'm going to start with the subtraction here. Okay, and I get log base 12 of 24 divided by 6. Because it's a subtraction, A, B, and I'm just kind of bringing it back. I'm going from here and I'm bringing it here. And then I'm left with plus log base 12, 36. And then I can simplify this. Log base 12, 24 divided by 6 is 4 plus log base 12, 36. Now I can invoke this rule here, because I have two logs with the same base being added. So this can become log base 12 of 4 times 36, which is equal to log base 12 of 144. Okay? And if I was to evaluate this, I'm going to convert it into exponent form to evaluate it. And I get 12 to the power of whatever I have. 12 to some power is equal to x, is equal to 144. And 12 to the y is equal to 12 squared. 144 is 12 squared. I have the same base now. Y is equal to 2. So this is all equal to 2 in the end. Okay, let's try another one. All right, we've got log base 3 of 27 times the square root of 3. And it wants us to evaluate this.
Well, I think the best thing for us to do in that case is to, so we're actually going the other way now. So we're here, we've got a base and we're multiplying two numbers, 27 and the square root of 3. So I'm going to separate them because we're just dealing with numbers now. So log base 327 plus log base 3, and I don't like the square root, I'm going to write that as 3 to the 1/2. It's the same thing, 3 to the 1/2 there. Okay, I can actually go ahead and solve this right away, just using here. And then this, well, let's figure it out. So before I go through and I solve everything, let's just, I'm going to use this power here, law, so plus 1/2 log base 3 of 3. Oh, but hey, I'm right here. A base and the number are the same. So this I know right here, this is equal to 1. Okay, so let's just do this part then. 3 to some power y is equal to 27. 3 to the y, 27 is the same as 3 cubed, so y is equal to 3. So then, this is the same as 3 plus 1/2, or 7/2, because 3 is the same as 6/2 plus 1/2, 7/2. Okay, that's the final answer on that guy. And I'm going to check my answer again, because I am insecure. 3.5, baby. 3.5, which is 7/2. Okay? Great. Okay. All right. One last, well, I'll do a couple more here. So we want to write this as a single logarithm. So I've got log base 9x minus log base 9y plus 4 log base 9z. Okay, and they want us to write this as a single logarithm. So basically I'm just doing the reverse of everything I was doing at the beginning of this video. So what I'm going to do, I've got a division here and I've got a multiplication here. So let's just do it. I'm going to work on this first. Log base 9 x over y. Okay, just using this rule here. But then I have plus 4 log base 9z. I've got to get rid of this 4 in the front here so that I can do stuff. So I have log base 9 x over y plus log base 9z to the power of 4. And now I can just go ahead and use this law and do the multiplication. So this all becomes log base 9 of x times z to the power of 4 over y. And I check my answer to make sure I did it right. I'm not leading you guys astray. And that is in fact the answer. Okay? Let us do I don't know. I'm going to do one more here. Okay, I'm going to do one more. And you guys can struggle and practice and do your best. So they want me to write this log base 5x plus log base 5 square root of x cubed minus 2 log base 5x. Okay, I have all the same bases, that's good. So that tells me that I can use my logs. Eye contact. I don't like radicals, so the first thing I'm going to do is get rid of that radical. X to the 1/2 times, so that's going to be 3 over 2. The square root of x cubed is the same thing as x cubed to the power of 1/2, and then I multiply, that's what I got there. Minus, and I'm going to put this back up there so that I can actually work with my laws. So minus log base 5 of x squared. Okay, I'm ready to do some stuff here. So the first thing I'm going to do is do the multiplication here. I could have started with the division, but I'm going to do multiplication. So I'm going to do this part and that. I use this rule. So log base 5 of x times x to the 3/2. And when I'm multiplying variables, or the same variables with different exponents, I can just add the exponents. Okay? So, and then minus log base 5 of x squared. So this becomes log base 5 of 2 over 2 plus 3 over 2, which is 5/2. And then minus log base 5 x squared. Now I can use this rule, and I get log base 5, x to the 5/2. I didn't put my x there before. So x to the 5 over 2 divided by x squared, using this here. And I know that when I am dividing the same variable with different exponents, I can just subtract the top exponent from or the bottom exponent from the top exponent. So this is the same as log base 5 of x 5 over 2 minus 2, which is the same as 4 over 2. And then that leaves me with a final answer of log, of 1/2, x to the 1/2. Which I can rewrite if I was base 5, which I can rewrite as 1/2 log base 5x. And I can never take the log of 0, so basically x has to be, or of a negative number, x has to be greater than 0 here. That's my restriction. I don't know why I put it up there. X has to be greater than 0. Okay, and let's make sure that I did that one correctly. 1/2 log base 5 of x, and x has to be greater than 0. We'll talk a little bit more about restrictions, but I'm not going to do that in this video. I think you have enough now to go and go forth and prosper. So until the next video.